everybody. My name is Ian Murdoch, and I am the Senior Manager of Analytics with Warner WB Games. And so let's just get into everything. So I'm going to jump ahead a second and tell you a little about what we do. And so we are a mobile game and console game publisher and developer, specifically for Warner's properties. And so the kind of games we make include what you see here, Golf Clash, Game of Thrones Conquest, Mortal Kombat on the mobile side, and on the console side, you see other games, not just those, but including Injustice 2, Shadow of War, the Shadow of War series, the Lego series, including Lego Worlds, and the Batman Arkham series. So now, how does the analytics fit into this? So going up to specifically what the WB Analytics side of things is, we support a wide variety of what is considered the publishing element of making a game. And what you see is this wheel here, and this wheel actually construes all of those elements. There's the acquisition side, like what does it take to actually acquire a user? What does it take to actually get them to download, install, and play your game, or be it on the mobile side or on the console side. The distribution side of things is how we're getting information to them and how are we getting content to them. The engagement, how are we sending push notifications to them? Are we reaching out to them via email? Are we doing all these elements to make sure that they have an engaging experience with us? We have the conversion. That's kind of a core business to kind of a core element of the mobile business, specifically around when you think about converting somebody from just being a passive user to actually making their first purchase. Are they going to purchase that upgrade pack? Are they going to purchase that first piece of content that's actually going to help them skill up and actually go deeper in their experience with us as our games? Then you have the retention side of things. Going forward, we don't just want somebody to download and play our games once, we want them to play our games continually. So there are efforts that we do to actually keep them on board and keep them retained. And then it all kind of, we have a wheel because it all kind of feeds together, and if any one of those elements falls, the entire thing kind of falls. And so analytics actually at some level at Warner feeds into each and every one of these things. So for example, what we might look at is what is the impact on sending an email to a player at the right time on their ability to be retained with us. So like if we reach out to you and tell you that this new content or this new DLC is available, what does that do in terms of your ability to stay with us and continue playing our games? And how does that actually improve our ability to actually keep the life of a player longer and healthier and happier? So what we're specifically talking about today is actually where we were before we started using specifically the AWS services and where we are now. So let's go through where we were. Before, we were getting 3 sources of data for our games. We were getting client telemetry, so that's telemetry specifically coming from the app itself. We were getting server telemetry. That's what's actually things that are being processed at the server side. And then we're getting what's called demographic information. But what you can really think of demographic information as is just any general information that we get about our players, either like the countries they get, the countries they're playing in, the regions they are, what kind of platform they have, those kind of things. But not just that, but actually competitive market information as well. What's going on in the industry? What are the top games? What's doing well? What's actually keeping people playing the longest, that kind of data as well. And we had those 3 different sources of information. And they're all going into our own in-house maintained relational database management system. And we were doing it once a day. So I want you to think about that for a second. Once a day, we're going to dump out all this data about all this information we have into the system, and we're going to hope that we catch and solve every single problem that's associated with it in enough time for people not to be furious with us. And I don't know if you know gamers, but a day is kind of a long time for that. And then on top of that, what we were doing is, since we didn't have necessarily any tooling on top of that, we had basically an attachment of SQL to a Tableau system. And basically we were saying, we have the data, it was within the last day, have at the game team or have at the publishing team, please try to make some sense and garner some insights from this. As you can see, it's not the most efficient system, and it's also not the easiest system to navigate and use. So we did a couple things about it. So, and this just kind of sums up what we're talking about. And actually, there is one more point that I do want to talk about. This system is not just inefficient and not the easiest to use, but because we were doing it ourselves, that means we had to make a significant outlay of financial expense to actually make it happen. So there was a big capital expenditure side of it as well, because we were actually making these systems ourselves and to actually store all this data, which is really painful when something doesn't, when you're on the tail end of a game and you still have to have all these resources still dedicated to it. So we actually instead, we looked at our system and we decided, well, let's actually break it up into different components and see what we can do with it. So the first thing we looked at is how do we take all of these different data and how do we integrate all that data? So what we use is we use a service called Avro. And Avro allowed us to take all these different schemas for all this different data and actually have an efficient way of actually combining all this data together using its schema merge system. Then we ingested the data, and we're using services like Spark, Airflow, and Kafka to actually take all this information and quickly digest it. Not just instead of just waiting a day to do everything, why can't we be ingesting that data even faster? And I'll talk about speeds a little bit later. Then there's the elements of storing the data, and so this is where we found AWS's services to really come in handy. So we take all that ingested data and we're storing it in our data lake, which is a AWS S3 data lake. And we're using AWS's S3 because bang for your buck, it's a great way of storing large amounts of data. And then on top of that, we're having that feed into our query engine, which is run on Redshift and Redshift Spectrum. And we're using Redshift and Redshift Spectrum because of their flexibility in terms of how you integrate them from the querying side of things. On top of that, then we looked at, okay, well now we have the data stored, we're getting the data. So now we actually have to be able to combine this data. So then we had our modeling layer on top of this. This is where we created our relationships. This is where we created how this table links to this table. And this is where we did some high level math on terms of how things are going to be loosely calculated. And for this we use services like Airflow and Zeppelin to a lesser extent. And then once you have all that modeling on top done, the final thing you need to do is you actually have a way of actually presenting that data so the insights can be garnered. And so for that, we're actually using services like Looker, RStudio, and Tableau. So that's kind of a streamlined way of looking at it, but let's actually see what this system looks like when it's actually in design. So we have our API. So we have all that data that I talked about before and the ingestion side of things. So we have client data, the app data. We have server data, those events that are being processed on the server side. And we have sales, market data, all that kind of other information there as well. Then what we're doing is we're processing those first two buckets because they're kind of loosely tied together. Client and server data. Server has nothing to process if the client's not doing its job. So you kind of tie those two together and we process that data together using Spark. And then we feed that data out into our raw data lake. And this is where all the raw data is being stored, again, using S3. And at the meantime, that daily data that is not from the game, but from these other sources, is actually just being fed into what we call our analysis lake. You'll see why we call this the analysis lake in a second, but that's just being fed into extracts that can be already pulled for assessment, analysis, and things like that. So we take that top layer, that client data, and we actually send it to what we call our game cluster. And so this is where this is our cluster of stored data, and this is where where our models are built upon. And so this is where we can then have the data built for different analysis. But sitting in that cluster is not necessarily the most efficient way to do it. So we tie everything together so that you can now actually interface your game data with your market data in your analysis lake so that everything can be done via that analysis lake for people to do to see how all these pieces of information are actually tied together. And then again, on top of that, you use the tools that you use to get insights. So this is Looker, Tableau, RStudio, Spark, and everything like that. And so just let's talk about what we're actually seeing with Redshift. So these are some of the benchmarks that we're testing ourselves and measuring ourselves by in our environment. So we've got about 30 Redshift clusters. We've got a dedicated pipeline per game, and which is very important. This is for anybody interested in game, actually the analytics and data side of game design. This is crucial. Before, we had a single pipeline that was processing for a variety of different games. That might not be perfect. A fighter game might need different things than a strategy game. It might need different processing speeds and different response times. With having a dedicated pipeline per game means that we're actually creating things for the title at hand. And then actually being able to take best practices between them, but actually still keep in mind what we're making at the time we're making it. So then on top of that, we have our storage. And right now we're sitting at about 110 terabytes in Redshift and about 750 terabytes in our data lake in S3. So yeah, but that's just actually where we are. Now we're actually going to say like the things that we want to measure ourselves by. How good are we with Redshift? And so with our Redshift environment, we can sustain a peak of about 100,000 events per second. So that means that if 100,000 simultaneous events are deemed by a single second are happening, we can still process them effectively. To give you kind of some perspective, our most intense game is about 60,000 events per second. So we're running at a speed that's almost twice what our biggest load is. And even that was like at its peak was 60,000. We're sitting at about 40 plus tables per game, and each of those is running smoothly, but that allows us to actually have specific data tables for each game. The number varies a little bit, again, going by genre, going by scale of the game, and going by those kind of things. But generally speaking, we're at about 40 tables a game. And instead of doing that whole 24-hour delay thing where you have to wait a whole day to respond to anything, we're sitting at a speed of about 6-minute micro batches, which means that we're able to then start sending data every 6 minutes so that we can then process it and use it at a much quicker rate than we did before. So this gives people who actually make decisions and do actions based off of this data much more runway to do things. Specifically, they get 23 hours and 54 minutes back to then actually try to make a change before the entire world blows up because they had to wait a whole day to do something. And then lastly, in Spectrum, we're on a monthly level, we're scanning about 800 terabytes a day, per month, I mean. And so when we think about what we've actually been able to really win with, not just with those numbers, but like the core things that our business needed that we're able to win with Redshift, the first element is operational flexibility. And by that, I mean specifically in the budget. Going back to what I said before, when we were creating all these resources ourselves, we had to spend the money on all the resources. We had to do that outlay of capital to have everything. And what that meant is that when, say, a game is on this tail end where not as many people are playing it, we're still footing the full bill for that entire game. The benefit of Redshift is that it can scale with you up and down, so that when a game is when it's the tail end of its life cycle, you're not actually spending as much, which is actually very crucial when you're making large-scale games, because you try to buy for a lot of players up front, knowing that the number of players is going to scale down over time. Then the other element is we've had faster recovery from issues, as opposed to us having to respond to every single issue ourselves. Having that ability to have external resources as well to respond to issues has been tremendous. The other element is scaling. Going back to that budget, it's not just about the finances, it's about the ability, that operational flexibility, purely from the perspective of if you have a burst, there's resources there that you don't have to go out and try to purchase and deal with gaps in your data and all that kind of stuff. It scales with you. And finally, it's just that external management really comes in handy. And then there's the element of the customer experience. and that's the customer being us. It makes it easier to model on. Redshift makes everything very easy to model on, to create these relationships between those 40 plus tables per game, and not just between in the game, but also the 40 plus tables that other games have to still tie them all together. And then it also actually comes with a set of tools that we can use to actually manage all of these things. So instead of us trying to design and develop all these tools ourselves, there are resources available to us that we can actually take advantage of. And then there's the element of portability, and this has been crucial to us. So while every game is a unique, precious snowflake, for the most part, there's a good amount of understanding that we still know that every game should have. We want to be able to know how many people are playing our games. We want to know we want to be able to know how many people are winning in PvP matches in our multiplayer games. We know those things are things that we know we want to track, and instead of having to design from the ground up every single time, one of these design from the ground up our data management system for every single one of these games, even though we know there's things that we want to track across the board, the portability, the ability to take this thing that we built for game A and just move it over to game B, copy it over to game B, and know that it's going to work is actually tremendously helpful as well. And then a couple of things that we've noticed from our time using Redshift. I'm just going to have them all up while I talk through them. It's just kind of like to be sure that you know what your needs are. There's different sides of things that we need. We need compute and storage, but to understand how much compute you need versus how much storage you need. That actually helps you determine what you are going to be requisitioning and what you're going to be utilizing. Again, same thing. By knowing that also feeds into your ability to determine what instances you need, so that you're not buying instances or reserving instances that are not suited to what your needs are. And then also things to think about are just resize speed and storage tiers. And going to just some other things to think about. These are just things, these aren't necessarily as quantitative, but these are things that you should generally think of when you're going through the early stages of your concepting. There's the idea of schema merge and evolution. So understanding the fact that you have all these different schemas for your systems and all for your different data sources, understanding think about how those might play together. Because if you end up having to do any form of combination or any form of merging or stitching, understanding how the schemas play together early really saves you a lot of headache. You can't catch everything, but if you think about it beforehand, it saves a lot of headache. Then there's a data retention strategy. This was super helpful. Sometimes you want to think that you want to store everything everywhere all the time forever and ever. But a lot of times you realize, for some of this stuff, I only need the last 3 months. I can move all of my history to S3, but in some of my Redshift tables, maybe I only need this stuff for the last 3 months. And understanding what data you need when and how much of really will play into how you use Redshift. And then there's the different speed of loading at different frequencies. I talked about the difference between a day and 6 minutes, but sometimes a day is fine. If your game is down and you're doing outage reporting, you want it as soon as you can possibly get it. If you're talking about, if you're literally just talking about something like number of players per day, like if that's literally the metric you're tracking, then you don't need it any other day. You don't need the system constantly sending you, nope, don't have the data yet, don't have the data yet, don't have the data yet every 6 minutes. You can wait 24 hours and be fine. All right, and so moving over, so going back to this, so a lot of our system was built on Redshift, but the insights are actually garnered through Looker. So we figured we should talk about some of the things that we got as wins through Looker. And for reference, a lot of this comes into play because of the fact that though a lot of people doing analysis, like in the analytics space, are technical, a lot of the people who need to consume data and gain insights from them may not be the kind of people who are going to go out and write SQL queries. So the first thing you need is something that's flexible for everybody. The first thing that we got is the ability not just to build models do modeling in Redshift, with Redshift data through our Airflow system, but also to be able to do modeling in Looker itself, to be able to actually create things and be able to tie them together was super helpful. And then actually creating what I'm calling playgrounds here, but it's the idea of these explorers. The idea that you can actually hand off to, say, a user acquisition specialist, a set of different data types that they can just do clicks and drags and create filters on and actually get data, the data that they need without actually having to do super technical work has been tremendously helpful for a lot of our team. Then there's the element of scaling. And this has been helpful. This is not about scaling like you think. This isn't about scaling with the users that you have. This is scaling in terms of the number of different ways to present data that you can have running at the same time. So I can create 5 different versions of the same type of dashboard filtered 5 different ways, or I can create a different dashboard for different groups of people relatively quickly. And then there's, on top of that, the element of AWS integration. Looker works really well with AWS. I've been using Looker for several years now, and my entire experience there, specifically always built on top of Redshift, has been really helpful, specifically with the Redshift spectrum tables. And then there's the element of the user experience. And so for people who are SQL savvy, going back one, there is still the element of you can write SQL queries in the Looker engine itself, and you can actually get all that data, you can format that data, you can actually then take that SQL query and turn it into a model and still be fine. And then you can actually turn that same model into a view for people to use downstream from you, just within 2 clicks of after your query is run. And then there's the element of creating dashboards, not just general dashboards, but these are easy to customize for. So even after you've done the complex work of creating this fancy dashboard with Looker, you can hand them off to somebody to customize relatively quickly. And then there's the idea of impromptu calculations, and this is specifically around in your tables with all these views and all this information. What we really want you to be able to do is garner insights. That's the word I keep saying. And sometimes that means that you have two numbers. We have the number of people spending money, and we have the number of people coming to the game. What we want to know is, well, how many people, what percentage, you can do the math in your head, or you can actually create a quick impromptu calculation in the table that will tell you, well, we have X% of our players are actually spenders. And all of that's easily done with Looker, which allows us for great wins.